All right, well, let's continue on with dynamic arrays. So you remember some of the limitations of arrays as we found them when we first started talking about them. They're fixed size, and we can't just make them be whatever size we need. We have to define them to be some size, and then we typically will only use part of them, and that's fine, particularly for small enough arrays. But now that we know how to create dynamic variables, we can actually create a dynamic array whose size is determined at runtime. So in display 9.4, we have this int pointer type. And they're going to use it to, first of all, point to an existing array. That works. An array is, we said that when we create an array, the array name itself points to the beginning of that fixed block of memory that holds the elements of the array. So it's kind of like a pointer already. And in fact, we can use a pointer to the type of the array the same way we would use the array itself. So we can set a pointer to integers to the address of an array of integers by saying p equals a. We can't do it the other way, a equals p, because a is a fixed address. It's an array. It doesn't allow you to change it. So now let's expand on that a little bit into dynamic arrays. So now, instead of just having an array and pointing to it and using p instead of a, we can create a whole new array, a dynamic array of whatever size we choose, by saying new data type and then square brackets with a number inside. And that's going to be a dynamic number that we just entered from the keyboard. And when we use that pointer variable, so a is an int array pointer type, which is a pointer to integers. With an index, it works exactly like a traditional array. We're still allocating a big chunk of memory that's holding the entire array. We're just allocating it at runtime instead of when we compile our program. Again, when we're through with the memory that we used, and in this case, it could be fairly large. I mean, it could be as large as the user running our program chooses, since we're not verifying this number anywhere. we still need to use a delete. In this case, we use a delete with an empty set of brackets indicating that it's an array, and the variable that points to the beginning of that array, and the memory management piece that gets built into our code figures out how to delete all of the elements of that array. Can I run that code? All right. Let's give it a shot. Okay, it's telling me there's a problem. Let's see if we can figure out what the problem is. My sort function is not there, so I need a sort function. We'll go to chapter 7 and borrow the sort function out of here. All right, let's see if it, now we can get it to compile. No, still a problem. All right, let's see if we get any closer now. All right. In this case, we created an array of 5. Theoretically, it would work with larger numbers, but I don't want to go to the trouble of filling out an array of a billion. Let's look at a couple more self-test exercises. Let's go to page 528. Ms. Hargrove, number 12, what would be the output of that code?
We create an array with 10 indexes, right?
So we have an array A of 10 elements. Actually,
9.
no, it's 10 elements, 0 through 9.
Oh, I'm sorry. I was even looking at the wrong one in my book.
Oh, okay.
No wonder I was confused.
So number 12.
Let me look.
This is basically the simple case where we're just using a pointer to point to an array. Integer pointer P equals A. We declare an integer pointer called P that points to the address A. What does this loop do? It's just storing the numbers, the index numbers, in the elements of the array. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. What is this loop going to do?
It'd be cleaning those out. With space in between.
Yeah, because P points to the same address as A. P0 is going to be the same as A0. So it's going to be outputting the same thing we just stored, 0 through 9. All right, Mr. Gear, number 13.
It's an array of 10.
Okay.
It's got CL 10, 1, 2, 3, 4, 5, 6, 7, 8, 9.
All right.
Because it's changing the address of the first block.
Changing the value, the contents of element 0. And since they both point to the same place, changing the contents of element 0 of array P changes the contents of array A because they're both the same array. You may also see some what's called pointer arithmetic in code that's out in the world. Look on page 529. This is an example of pointer arithmetic. The contents of D plus I. What happens is it adds, instead of the literal value of the integer to the address here, it adds the value of that integer times the size of an element. So if integer is 2 bytes, then it would be 2 bytes for each I. So I5 would be 10 plus the address, which means that's exactly the same as writing it this way. So why you wouldn't just write it this way to begin with, I don't know. This is the way I would recommend writing it, rather than using pointer arithmetic. All right, let's talk about multidimensional dynamic arrays. In a multidimensional dynamic array, we're doing something a little bit tricky. We're actually, instead of making arrays of element type, we're making arrays of pointers to, arrays of pointers to, arrays of pointers to element types. So in the simplest case for a multidimensional array, a two-dimensional array, we have row and column dimensions. They call them D1 and D2. Why they couldn't just say row and column, I don't know, but D1 and D2. We have an interarray pointer type, and they declare a interarray pointer M and allocate a new array of size D1 of interarray pointers. That M is going to point to. And then for each element of M, we need a new array of the base type integer of size D2, the column dimensions. So for each row, we have a column of integers that we point to from each element of the first dimension. Does that make sense? So if we want a 5 by 5, we enter 5 and 5. It creates a array of 5 pointers, and each pointer points to 5 integers. And we can then store values in each element of each row, each element of each column, or let's say each column of each row of that two-dimensional array. And C++ knows how to tell it that this first dimension is a pointer to another address that the second dimension will give us the offset into the element that we need to get to. When we're done, to delete all of those, we first delete each of the arrays that are pointed to by the first dimension. So that would be the arrays of integers that are pointed to by each pointer. So we loop through all of those. And finally, we delete the array of pointers. If we went further than 2 dimensions, you can see how it could get kind of complicated. But we'll only do 2 dimensions. And this program is going to be useful to you because our assignment for next week is going to be using a multidimensional dynamic array. It's number 3, which refers you back to Project 11 in Chapter 7. Everybody remember Project 11 in Chapter 7? The airplane. And it's going to be a little more complex than the project in your book because I want you not to just input the number of rows in the plane. I want you to input the number of seats in each row as well. The good news is that if you wrote your functions well, you will not have to change them very much in order to use the new thing. It will just involve changing the parameter list. It won't involve changing the contents because the way you refer to a multidimensional dynamic array when you're using its elements is exactly the same as the way you refer to the elements of a multidimensional array that's not dynamic. And just for the heck of it, I've got some code that I've written previously. So this is a good starting point if you want to figure out how to create a two-dimensional array, put values in it, and delete them at the end. Go here and I'll clean this up a little bit so it looks a little better. Did we use characters for our two-dimensional in the example that we did in class? Seems like we did.
Yes.
So you'll notice I've got a char array or a char array and a char2 array. And I've defined char2 array as a pointer to char array, and a char array is a pointer to char. I want my chart or my multi-dimensional array in this case to be a char2 array, a pointer to pointers to chars. I have the user input number of rows in the plane and the number of seats in each row. I store those in rows and seats. So here's the part where I create the array of pointers to characters and store in a character array pointer, or I could have said char2 array, right, because that's the same thing, right? Here in display seating, other than changing the parameter, this should look identical to your original display seating. And in fact, I think this probably should run. Let's take a look. Well, let me set a breakpoint here. Well, that's okay. It's going to stop it. That's okay. So if I want 15 rows and 9 seats on each row, looks like it generated what I asked for, except it should call this first row 1 instead of 0. And let's go back and look at the assignment. Revise the airplane seating program to use a multi-dimensional dynamic array instead of just a dynamic array, as they say. Ask the user for both the number of rows and the number of seats per row for your airplane. Okay, that's in addition to asking for the number of rows as stated in the book. And include 1 or more aisles as appropriate. So I'll leave it up to you to determine what's appropriate, but I've been on a plane with 9 seats on each row, and they've done it, well, I've been on one that had 2, 5, and 2, which I'd have to say is, I don't think is the ideal seating arrangement, but when you have 9 seats in a row, what are you going to do? 2, 5, and 2, that's one arrangement I've seen. Another one is 3, 3, and 3. So we have 2 aisles. You have to determine when to have 2 aisles versus 1 and where to put them. But before I go any further with that, we've got, I
Go
guess,
ahead, do whatever you need to do.
yeah, I'm at a stopping point here, so
Okay.
I'll let our guest introduce himself. And I'll give it to him.
All right, CIS 2103, right?
That's us.
Sounds good, doesn't it?
Yeah.
One of the favorite classes most of you are taking, I'm sure. I got a little sign-in sheet here for you, if you don't mind signing in that for me. And I'll get Todd, we'll do that one too. And then I'm Gil Smith. I'm Career Service Specialist here at OSU Oklahoma City.